Hey Science 8, it's Mr. Drzezinski. This is a video that's going to support the water systems evaporation experiment. You'll find it in the Google Classroom. And you should have that sheet ready as you watch the video and complete these questions. The instructions suggest that you complete the scientific investigation to solve a testable question. Does water or ice evaporate more quickly or faster? Okay, I'll do that experiment here. You fill in the sheet. The first question asks you to write the hypothesis. Do you remember the hypothesis format? The hypothesis format: if, then, because. Start out with the word if. Following the word if is the thing that the scientist changes. That's the independent variable, And in this case, the thing the scientist changes is going to be water or ice. Followed by the word then, followed by the dependent variable, which is the thing the scientist measures. In this case, we're going to measure how long it takes for water to evaporate or the ice to evaporate. After that is because. Because is followed by a reason. Okay? If I was to complete that hypothesis, it would read something like, if 10 milliliters of water and 10 milliliters of ice are placed in dishes, then the water will evaporate faster because the molecules are moving faster to begin with. Okay, write the hypothesis. Question number 2, you have to do some research. List the 3 states of matter. List the 3 states of matter. 2B reads, list the elements that make up water. 2C reads, list water's chemical formula. 2D reads, describe condensation. You can look up condensation. That's when water vapor turns to water droplets. Water cools down, the molecules stop moving so fast, and they'll collect together in a droplet. 2F, describe evaporation. Evaporation is the opposite, when water droplets start to speed up so much that they escape and become water vapor. Liquid water turns into water vapor. Step 3 asks you for a procedure. Here is the procedure. I started by placing 10 milliliters of water into a dish. Step number 2, place 10 milliliters of ice into a second dish. This one is empty. I had pre-frozen 10 milliliters of water and turned that to ice and put that in the second dish. Step number 3, place the dishes on the table and start the timer. Step number 4, when all of the fluid is evaporated, record the time. So I'm sure this will take a while. Actually, I'm not even going to do this experiment. I'm going to find some times and use it for the data. Step number 4, when all the fluid is evaporated, record the time. Step number 5, you should repeat steps 1 through 4 for 2 more trials. Step number 5, repeat steps 1 through 4 for 2 more trials. And that'll be all the instructions that you'll need. You can leave the other steps blank. Question number 4 asks for the independent variable. The independent variable is the thing the scientist changes, in this case, water or ice. 5 asks for the dependent variable. The dependent variable is the thing the scientist measures. In this case, how long in minutes does it take for the water to evaporate? How long in minutes does it take for the ice to evaporate? That's what gets measured. Step number 6, the constants. Well, the constants in this case are 10 milliliters of water or ice. 10 milliliters. The constants in this case are these dishes. The constants is the environment that they're put in, the room temperature, the room humidity, the room pressure, the atmospheric pressure. All of those things are the same. okay? And the way they're timed and recorded. Step number 7 are the materials that we need. Well, we're going to need some distilled water or water. We're going to need something to make ice like a refrigerator. We're going to need the graduated cylinder. And we're going to need 2 dishes. A timer. I think that's all that we need. List those things on number 7. If you scroll down, you'll be asked for the data table. I have already filled the data table in on your sheet. It shows trial 1 for water took 320 minutes, trial 2 took 312 minutes, trial 3 took 308 minutes. That's for the water. Trial 1 for the ice was 390 minutes, trial 2 was 412 minutes, and trial 3 was 386 minutes. What I'd like you to do is use your calculator and find the averages in minutes and fill in the last column of averages. I'd also like you to go to the slides. There's a second file in your Google Classroom for water evaporation experiment slides. And I'd like you to make the table and the bar chart on slides. You'll have to type out trial 1, trial 2, trial 3, and average. You'll have a row for water, a row for ice. Put all those values in and find the average. And then use a pull-down menu that says Insert Chart and put that chart out there. The chart should have a title. The axis also should have a title. Okay? This chart can be copied and pasted back into your document. And that'll be the data table and the data graph. Number 10 asks for observations. The observations here I will give you. The water seemed to be evaporating as the ice was melting. The ice seemed to evaporate after it melted. The ice took longer. Number 11, the conclusion. We find that the hypothesis was supported. The water took an average of 313 minutes to evaporate, and the ice took an average of 396 minutes to evaporate. So write that as your conclusion. The hypothesis was supported, and then just give some data about the results. Question number 12, the source of errors. I think I gave this one to you also. We never really measured the temperature of the ice or the water. That might be a source of an error, not measuring the temperature of the water. We didn't measure the temperature of the room or the humidity or the pressure, the air pressure in the room. That might have an effect on the results. Okay, and the results might be different in different locations. Put a couple things in there for the air. And the last thing to do on here, further study. What can we check in the future? Well, we could check to see if water or milk evaporated faster. We could check to see if water or salt water evaporated faster. We could also see how ice evaporates in a refrigerator, freezer, I should say. We could try measuring the speed in which water evaporates in a freezer, because it does, and it'll go right from the solid state to the gaseous state in the freezer. Okay, I wanted to review an experiment because we've done some earlier in the class, and they're important to prepare for the PSSA test. See if you can finish that and submit it for me. Thank you.